Hi everyone, welcome. Today we are diving into a fascinating coding puzzle. It comes from Jane Street, a company known for its challenging programming problems. This particular one is called the Codereview Bug Byte puzzle. It highlights a very subtle behavior in Python. We will explore how Python handles comparisons between different object types. The puzzle asks us to find a specific value. Let's call this value b. This b needs to satisfy two conditions simultaneously. First, the expression b equals b backslash xff must evaluate to true. Second, the expression b is b backslash xff must evaluate to false. This sounds straightforward, but it often trips up experienced developers. The core of this puzzle lies in understanding the difference between the equals operator and the is operator in Python. The equals operator checks for value equality. It asks if two objects have the same content or value. For example, 1 equals 1 is true, and hello equals hello is also true. On the other hand, the is operator checks for object identity. It asks if two variables refer to the exact same object in memory. If you write x equals 1 and y equals 1, then x equals y is true. But x is y might also be true because Python often interns small integers or short strings to save memory. However, if you create distinct objects, is will be false. For instance, is always false because each creates a new list object. The puzzle's target byte, b backslash xff, is a byte's literal. Bytes objects in Python are immutable. If we simply set b equals b backslash xff, then b equals b backslash xff would be true, which is good. But b is b backslash xff would also be true, because Python often reuses identical bytes literals. This would violate our second condition. So, b cannot be the same bytes object as b backslash xff. We need b to be a different object entirely, but one that Python considers equal in value to b backslash xff. This is where byte array comes into play. A byte array is a mutable sequence of bytes. It's like a list where each element is an integer between 0 and 255. Crucially, byte array objects are never interned in the same way bytes literals might be. Every time you create a byte array, you get a new, distinct object in memory. Even if two byte array objects have identical content, they are separate objects. To solve the puzzle, we need to create a byte array that contains the byte represented by backslash xff. In Python, backslash xff is the hexadecimal representation for the integer 255. So, we can create our b like this. b equals byte array, 255. Let's test this solution against the two conditions. First, b equals b backslash xff. This expression evaluates to true. Python is smart enough to compare the contents of the byte array with the bytes object. It sees that byte array, 255, has the same single byte sequence as b backslash xff. Both represent a single byte with the value 255. So, the first condition is perfectly met. Now for the second condition. b is b backslash xff. This expression evaluates to false. This is because b is a byte array object. b backslash xff is a bytes object. They are fundamentally different types of objects, even if their content is comparable. Furthermore, even if we compared two distinct byte array objects with the same content, byte array 255 is byte array 255 would also be false. Each byte array construction creates a new object in memory. Therefore, b equals byte array 255 successfully satisfies both conditions. It is equal in value to b backslash xff but is a completely separate object in memory. This puzzle serves as an excellent reminder about Python's type system, object mutability, and the critical distinction between value equality, equals, and object identity, is. Understanding these nuances is vital for writing robust and bug-free Python code, especially during code reviews where such subtle issues can easily be missed. Thank you so much for watching this video. I hope you found this explanation helpful and enjoyed solving this classic puzzle with me. If you learned something new or simply enjoyed the content, please consider giving this video a like. And don't forget to subscribe for more coding challenges, programming insights, and deep dives into interesting technical topics. Your support truly means a lot and helps the channel grow. I look forward to seeing you in the next video.